Hello students, so here we are going to use a cantilever method to analyze a frame. Okay, so analyze a frame as shown in figure. So let's see a question. This is a cantilever method. So we know that for that portal method and cantilever method, they are useful for the horizontal forces, right? So for the cantilever method, let us consider we have to analyze the frame as shown in figure. So this is a frame, and this particular frame is having a span of 4 meter, 5 meter and 6 meter. Okay, this is a 3-bay frame, 4 meter, 5 meter and 6 meter. Okay, and it is a 2-story frame. So there is one story over here, and it has a horizontal load acting on it, that is 24 kilonewton and 36 kilonewton. This is 24 kilonewton, sorry, this is 12 kilonewton and 24 kilonewton. So it is 12 kilonewton load acting and 24 kilonewton load acting. Okay, now the name, let's label the beam A, B, C, D, E, F, G, H, I, J, K, L. Okay, so these are the labeling, and the span is given as 4 meter, 5 meter and 6 meter. So this is the span given. Okay, now let's see the steps to solve this problem. So our question is basically to analyze the frame. Analyze the frame. And what is given important, that area of column, area of cross section for our columns are same. Okay, now let's see the steps. So first we have to locate the centroidal axis. We have to calculate the centroidal axis. Calculate CG for hold the frame. Okay, we have to calculate centroidal axis over here. Then we should calculate what are the axial forces in column for the calculate axial forces. Axial forces. So we'll calculate for the first story first and then the second story. Okay, for first story and then second story. Then we are going to calculate shear at the end of the beam. Okay, so we are going to calculate what is the beam shear, and then we are going to calculate what is the beam moment. So what is the moment at the end of the beam. Okay, now let's start with the step number 1. So let us consider any section over here. Okay, let us consider that the centroidal axis, a tentative, okay, imaginary. I'm just using a dotted line over here. So on this line, let us call this line as a YY. So we have to find out what is the CG, okay, where that CG is at this particular line. Okay, on this line YY, CG is acting. So that's what, let's assume any YY line where CG of the whole frame is acting. So let us find out what is the X bar. So what do you mean by CG? CG is nothing but what is, overall distance with respect to each column. So that's we are going to calculate. So CG, formula for CG is nothing but A1 X1 plus A2 X2. So there are 4 columns, right? 4, you can see 1, 2, 3 and 4. A2 X2 plus A3 X3 plus A4 X4 divided by A1 plus A2 plus A3 plus A4. but we know that, you know, the A1, A2, A3, A4, the all areas of the column are same. Okay, so here when you say, when you consider these particular columns, okay, so they are the column number 1 and 2, so there are two areas. Okay, there are two areas over here. And what is the CG distance? Okay, so if we consider this as a reference line, okay, we calculate from this particular reference line, so we may consider that this is the reference line. So x1 will be, in this case it will be 0. Okay, so a1 is a1, a2, a3, a4, they are all same. Okay, area of cross section is same throughout the column, but there are two columns, so we can write that 2 into 0. Okay, because x1 reference about the same line, so that is 0. Then a2 again we can write that 2 into x2. So what is that x2? So x2 will be this particular distance, that is 2 into 4. Then again 2 into x3. So what is the x3? So let us consider 4 plus 5. Okay, that is 9. So this is 4 plus 5. Then let us see a4. So again a4 is nothing but, since two columns are there, so 2 into our distance is 4 plus 5 plus 6. 4 plus 5 plus 6, so that is 15. So this whole thing divided by 2 plus 2 plus 2 plus 2, 8. Okay, so when you do this calculation, we get x bar is equal to 7 meter. Okay, so the distance what we got here, the distance, this distance is 7 meter. Okay, so if this is 7 meter, so what will be the remaining? So total is 16, right? 5 plus 6, 11 plus 4, 15, sorry it is. So 15 and this is 7, so remaining will be 8 meter. So x bar answer what we got it as 7 meter. Now when x bar is 7 meter, okay, now let's see what is x1. So what is the distance for the first particular, this first particular column line with the CG line. Okay, so let's show the distance first. So this is our x1, then distance from the second column line x2, then distance from the third column line, so let me draw this way, x3, distance from the fourth column line, that is x4. So this is x1, x2, x3 and x4. Okay, so what is x1? X1 is nothing but our x bar, that is 7 meter. So let's write x1 is equal to 7 meter. Now what is x2? X2 is, now we know this is 7 meter. So it's very easy to find out what is x2. That is nothing but 3 meters, right? Because this is the 4 meter distance. Then let us see what is x3. So x3 is equal to, the total distance is 9 meters. So 9 minus 7 is equal to 2 meter. And then x4 is equal to 15. Total distance is 15. 15 minus 7, that is equal to 8 meter. Okay. So here we are done with all the CG distances. Now let's see what are the axial forces in the first story column. Or you may call it as step 2. So let's see what are the axial forces in the first story column. So let's quickly again draw this. So this is ABCD and the first story only we are drawing it here. This is our CG line. So CG is coming somewhere here. This is our B line. Then this is our C line. So let's draw. This is A, B, C, D. This is 24 kilonewton. This is 12 kilonewton. And this is F, G, H. This is E point. Okay. Now let us consider a vertical shear here. Okay, vertical force as V1. So let us consider, to keep it in balance, let's consider that this is going down. Okay, these two forces going down. and these two forces are going up. V3 and V4 are going down. Okay, so the axial forces in the column EI, this is I part. Okay, this is I, J, K and L, and this is 4 meter, this is 3 meter, and the bottom is 4 meter. This is 3 meter, this is 4 meter line. Okay, now we know what is x1, x2, x3, x4. Again I am writing so that we will need it in our calculation. This is x1, x2, this is x3, this is x4. This is x4. Okay, so let the axial force in the column, so let's say that EI, axial force in the column EI, okay, EI is equal to V1 is equal to V. Okay, it is the axial force. Now as the area of column, okay, area of columns are equal as you know, in question only it's given. So axial forces in the column can be written in the proportion to their distance. Okay, so we can return we can derive a relation between them. So we can write from our figure that V1 by x1 is equal to V2 by x2 is equal to V3 by x3 is equal to V4 by x4. Okay, so V1 by x1, V2 by x2, V3 by x3 and V4 by x4. So we can write like this. So with this we can actually find out, you know, what is that distance x1, x2, x3, x4 here. How? So just see, V2 is equal to, from this we can write the relation V2 is equal to V1 x2 by x1. So V1 is equal to sorry, with this we can find out what is the V1, V2, V3. I'm so sorry. So here actually we have the distances for x1 is equal to 7 meter, x2 is equal to 3 meter, x3 is equal to 2 meter. These are the, already we have these values. Okay, so we have this x2 by x1, so we can write V into what is x2? It is 3 by 2. Okay, so we get this answer in terms of V. So 0.28 V2 will get 3 by 2 means it will be V2, sorry, it is x2 by x1. x1 is 7 meter, it's not 2 meter. So it is 0.43 V. Okay, and it is going upward. Then V3, from our equation we can write V3 equals to V1, V3 x1 equals to V1 x1. So we can write V3 equals to V1 into x3 by x1. So V1 is nothing but V, x3 is 2 by 7. So we get here as 0.28 V, and V3 is going downward. Okay, that is our assumption. This is our assumption that it is going downward. Okay, V3 and V4 they are going downward, so these are going upward. The opposite sign we have to take, sorry. So they are going upward. Okay, then V4 is equal to, again we can write V1 x4 by x1. So we can write 8 into, this is 8 by 7. So we get the answer as 1.14 V. Okay, so we have calculated V1, V2, V3, V4 in terms of V. Now we need to find out what is actually the V. So to calculate V, let us consider moment of all the forces about point of contraflexure. Okay, so what is the point of contraflexure? Point of contraflexure is that where moment is 0. Okay, so there is a point of contraflexure. So you can see that for this case, in the middle of the column we can consider the point of contraflexures. Okay, so let us consider to calculate V. Consider moment. So this is point of, let us call it as M. Point of contraflexure M. Okay, so now see the moments. So what we can write, there are, what are the forces available? So 12 into perpendicular distance. So this is 3 meter and this is 4 meter, right? This is 4 meter, so half of the distance. So 3 plus 2 is 5. So we can write that, and the clockwise is positive. So 12 into 3 plus 2, right? What is 3? 3 is the length of AE, and this is half of the distance. Then there is a 24 kilonewton load acting, so that is 2 meter. Now let's see the V1. Okay, V1. So V1 is in the same line of action, so V1 is 0. Then there is a V2. Okay, so V2 into this span is 4 meter. Okay, this is 4 meter. So we will write 4. Then there is a V3. Okay, it is going in opposite directions. 4 and this is 5 meter actually. FG is 5. So we can write that V3 into 9. And then V4 is total span 16. Okay, so when we solve this, we get here we know that V1, V2, V3. Okay, so we can simply write them in terms of V. So with this we get the answer as 108 plus 4V minus 9V minus 16V is equal to 0. So the V answer we get it as 5.14 kilonewton. Okay, so this is nothing but our answer V1. Okay, so when we write this, then with this we can calculate what is V2. So what is V2? V2 is nothing but 0.43 into 5.14. Okay, we have all the answers in terms of V1, V2, V3, V4. So here when we get the step above it, I don't want you to get confused in this case. Okay, so when we get this relation, okay, simply substitute. Like V2, we know V2 is equal to 0.43 V. Okay, so when we substitute those values here, like for V2 you will substitute 4 into 0.43 V. Okay, so that value we will substitute. So with that case we will get our answers. Let me just do the calculation. Let me do the calculation for you. Okay, so this is 12 5s are 60 plus 48. This is 24 into 2, 48. Okay, plus 4 into V2 minus 4 into V2 minus 9 into V3 minus 16 into V4 is equal to 0. Okay, now 60 into 48, that is 108, plus 4 into V2. 4 into V2, what is V2? V2 is 0.43 V. So 0.43 V minus 9 into V3, 0.28 V minus 16 into 1.14 V is equal to 0. Okay, so with this we'll get the V value. So let me just check the answer. 108 plus 4 into 0.43. So it is 1.72 V minus 9 into 0.28, 2.52 V minus 16 into 1.14, that is 18.24 V is equal to 0. Okay, so when we add them up, 18.24 plus 2.52, so 19.04, V is equal to 108. So the V answer we are getting as 108 divided by, so it is 5.67. It is 5.67 kilonewton. So once you get V, then it is very easy to find out what is V2. Okay, so what is V2? V2 is nothing but 0.43 into 5.67. So the answer is 5.67 into 0.43. So it is 2.43 kilonewton. Then V3 is equal to 0.28 into 5.67. So 5.67 into 0.28, 1.58 kilonewton, and then V4 is 1.14 into 5.67. So V4 answer is 5.67 into 1.14, 6.46 kilonewton. Okay, So just you can verify your answer that total, upward force should be equal to downward force. So when you add this V1 plus V2 and this when you do this addition, so total should be 0. Okay, so when you do the summation of them, because these two are there going downward and these two are upwards, right? So just do the summation of V. So it is 5.67 plus 2.43 minus 1.58 minus 6.46. So it should be 0. So let me just verify it. 5.67 plus 2.43 minus 1.58 minus 6.46. Okay, so it is 0.0. Okay, so approximately 0. There are some digits over here, but we should get it 0. Okay, so slight manual error will be there. So we are done with the calculation for moment. So we have done calculation for V1, V2, V3, V4. Now we have to calculate the axial forces. Okay, now let's calculate axial forces in second story. Axial forces in second story. So quickly draw the second story here. So second story is like this. So this is A, B, C and D, and the force acting here is 12 kilonewton. Okay, the upper story. And again here point of contraflexure will be M. So we know that this is 2 meter. Now here let us consider here V1, V2, V3 and V4. Okay, so these are not the same forces. So we may consider as V1, V2, V3, V4, or we may just consider the dash V2 dash, V3 dash, V4 dash. Okay, to separate it from the previous calculation. G and H. Now here let the axial force, okay, let us consider that axial force in AE is equal to V1 dash. Okay, V1 dash or V dash. Now let us consider moment at point M. Okay, consider summation of moment at point M, because it is a point of contraflexure, and at the contraflexure moment is 0. Okay, so let us consider the moment. So what are the equations we will write? So it is 12 into 2 meter. Okay, so 12 into 2 plus V1 dash is equal into 0. This is V1 dash. Okay, we are writing it as V1 dash. Then plus V2 dash into this span is 4 meter minus V3 dash into 9 minus V4 dash into 16 is equal to 0. So when we again substitute values here, okay, so what we got here, with the previous, what are the previous relations we had now? V2 dash is equal to 0.43 V dash. So we have to use the same relations. V3 dash is equal to 0.28 V dash and V4 dash is equal to 1.14 V dash. Okay, so when we substitute these values, we get the V dash is equal to 1.26 kilonewton. Okay, that is our answer over here. So when we write V dash, then we get the answer as V2 dash is equal to 0.454 kilonewton, V3 dash is equal to 0.535 kilonewton, and V4 dash is equal to 1.436 kilonewton. Okay, so here we have done with the shear force in second story. Now the next step, that shear force at the beam. Okay, so beam shear we have to calculate. So calculate the beam shear. Now let me just take the next page. So let me copy this diagram. So here we are calculating beam shear. Now at this point we know that V1 dash is equal to 1.26 kilonewton, V2 dash is equal to 0.54 kilonewton, V3 dash is equal to 0.35 kilonewton, and V4 dash is equal to 1.436 kilonewton. Okay, these are the values we have calculated. Now V1, V2, V3, V4, these values also we have. So V1 answer we have, it was 5 point, the previous It was 5.67, 2.43. 5.67, V2 is 2.43. Then there is this V3 and V4. Okay, this is, they are going upwards. So yeah, here also there is a mistake. This direction I should draw it upward. So let's see the values for V3, V4, that is 6.48 and 1.5, 6.46, 1.58. 6.46, 1.58. Okay, so these are our values. Now let's see, we have to find out what is the beam shear at the end of the beam. Okay, so let's see the joints. So joint E. So at joint E, we can write FE. Okay, shear force we are finding out. So shear force at E joint. Okay, so shear force or force, whatever you call. So here, what are the force? Okay, so it is 1.26, 1.26 minus 5.67. Okay, then at joint F. At joint F. So what is the shear force? F of F. At joint F, we can write it as, now whatever answer we get here, just a minute, let me calculate. 5.67 minus 1.26. So our answer is 4.41. So this answer is 4.41 kilonewton. That is negative. Okay. So this is for FE. Okay. FE. I'm sorry. This is a beam shear. Okay. FE, where we got the answer here at joint E. Now let's see what is the force at F, at joint F. Okay. So that force will be minus 4.41 plus 0.54, 0.54 minus this one, this force we have to add, minus 2.43. So we get some answer here. Let me check what is the answer. Minus 4.41 plus 0.54 minus 2.43. It is minus 6.3. Minus 6.3 kilonewton. Then there is a joint. So this we have done with joint H. Now let's see the joint G. So at joint G, what is the force at G? So here the previous calculation, just carry over that, add that, minus 6.3 minus, use these forces, 0.35. In that, joint, what forces are there, we have to do the summation. 0.35 is minus 0.35, and there is the addition of plus 1.58. Okay, now when at this point we are adding, okay, both of them are going upward, but this is going away from the joint. Okay, so that's why it is a negative, and this particular force is coming towards the joint, that's why it is a positive. So that sign convention also we have to follow. So minus 6.3 plus 0 minus 6.3 minus 0.35 plus 1.58. So here we get the answer as minus 5.07 kilonewton. So F of G. Now let's see what is the joint H. So for joint H, that is F of H is equal to, the forces are, the previous calculation forces, minus 5.07 minus 1.436 plus 6.46. So this should give me a 0 answer. Then my calculation is correct. Minus 1.436. Okay, so it's almost 0. Okay, so our slide 0.00 something is there. So that is almost correct answer. Okay, now let's see joint A. Let's see a joint A. So for joint A, what is force there? F of A. Okay, so we can write it as V1 dash. So V1 dash force is 1.26 kilonewton. Now let's see joint B. Okay, so for joint B, we can write it as F of B. So that is nothing but minus 1.26 minus 0.54. Minus 1.26 minus 0.54. So we get the answer as minus 1.8 kilonewton. This is a lengthy calculation. So, but when you practice it for the 2-3 times, so you will get it. Now for C joint, it is minus 1.8 plus 0.35. Okay, this force. So whatever we got the calculation, that we are taking it and adding the next force. So we get it as minus 1.45 kilonewton. Then at D point, F of D, it is minus 1.45 plus 1.436. Okay, so again it is almost approximately 0. Okay, some slight error is there, but that is fine, acceptable. So this is our beam shear calculation. Now the last step is to calculate moment at the end of the beam. Okay, so last step is we have to calculate what is the moment. Now let us see. M of EF is equal to M of FE. M of EF equals to M of FE. So we can write this particular is equal to F of E, okay, force into that particular span by 2. Okay, F of E. Now just now we have calculated what is F of E. So F of answer for F of E is equal to, this is the F of E. Okay, this F of E, that is minus 4.41 into 2. Okay, so that is 8.82 kilonewton meter. Then M of Fg. So just see what is the value of M of Fg, that is 5.07. So for here F of F into the span is 5 by 2. So it is 5.07 into 5 by 2 is 2.5. So let's see the answer. Then M of GH. M of GH is again equals to M of HG, and the answer will be F of G into 6 by 2. Okay, the next span is, this is 6 meters, so we have taken 6. This is 5 meters, so we have taken 5, and this is 4 meters. So here we get the answer as F of G. Okay, F of F is 6.3, it's not 5.7. This is 6.3. This is 6.3, this is 5.07 into 3. Okay, so these answers we will write. And then second story. So for second story also, M of AB is equal to FA into 4 by 2. Okay, FA into 4 by 2. So what is FA? FA value is 1.26 into 4 by 2. So we get the answer as 2.52 kilonewton meter. Then M of BC is equal to F of B into 5 by 2. That span is 5 by 2. So here we get it as 1.8 into 2.5. So it is 4.5 kilonewton meter. And then M of CD is equal to F of C into 6 by 2. So F of C is 1.45 into 3. So our answer is 4.35 kilonewton meter. Okay, and here the calculation about M of Fg, 6.3 into 2.5. So it is 1.575 kilonewton meter. And this is 5.07 into 3. So 15.21 kilonewton meter. So here this is our last step. So here we have calculated moment at the end of the beam. So students, for the cantilever method, we have these steps. So first we have to locate the centroidal axis. Okay, we locate what is the centroidal axis. We have started with this centroidal axis, and then we have calculated what are the axial forces, okay, in the column. So we have first calculated this, then we have calculated as axial forces in the column. For the first story we have calculated, and then we have calculated for the second story also. Okay, so once we are done with this, then we have calculated what are the shear at the beam and what are the moment at the beam. Okay, so this is lengthy problem, but we need little practice, then it's easy. But okay, so students, hope you have understood this question, and thanks for listening.